All right, so yesterday we were talking about finding critical values. Again, that's where your derivative is equal to 0 or does not exist, and you have to make sure that the critical values are in your given interval. All right, so now building off of that, we're going to use what's called the closed interval method for finding absolute extrema. All right, so we're be able to figure out what an absolute max and absolute min is from a graph. Now you're going to be able to know how to do it from an equation. All right, so you have to make sure that you have a continuous function on your closed interval. So the first thing you need to do is identify your endpoints. All right, that would be your interval that you're given. Seneca, I have steps for you. The next step is you want to identify any critical values in the open interval. Be sure to check that they're in the domain and in the specified interval. So any critical values, again, that's when your derivative is equal to 0 or does not exist. Then what you're going to do is you're going to evaluate the original function at both of the endpoints and then also your critical values. And then the highest one or the largest value will be the max, the smallest one will be the min. So it's a couple steps, but it's not too difficult. All right, so determine if the EVT applies. If so, find the extrema of f of x from -1 to 2. All right, so what type of function is that? Right, so what is its domain then? No. What's the domain of a polynomial? Right, so regardless of whatever I plug in, I'm always going to get an answer out. So if it's continuous for all real numbers, it's going to be continuous on -1 to 2. All right, so the EVT is going to apply. So we are going to find a max and a min. All right, so since f of x all real numbers. You could do that too for all values of x in the set of real numbers. So since the entire equation is continuous, the EVT will apply on a closed interval. All right, so we have to find now our critical values. Right. So we have f prime of x, we know is 12x cubed minus 24x squared. And no. So extrema would be like the highest value or the largest value and the smallest value. That's what we're trying to find. Critical values are just possible places where they happen at. So we're just trying to figure where could it possibly occur at. All right, so I could take out a 12x squared, and I'm left with x minus 2. So that leaves me with x equals 0 and 2. Yes, it would. Yep. So that would be what? 3, right? And that would be 3. Okay, so again, you want to make sure that you're looking at your interval again. So I know 0 is on my interval, so that's good. 3 is not, so I'm not even going to use them. Okay? Because this is what they give you, right? So 3 is not in between those two numbers. All right, so This is not, the x equals 3 is not in this, right. Right. Not in your interval. Okay, so now you have to test the endpoints, so -1, +2, and then also your critical value, which we know is 0. All right, so you're plugging that into the original equation. Right, yep. So if I plug in -1, I get 3 plus 12. The original, right. Yes, yep, because that's where the derivative is equal to 0. All right, now if I plug in 2 into the original, 2 to the 4th is 16 times 3, which is 48, minus I think it's minus, right? 2 cubed is 8. Yeah, that should be minus 96. And then if you plug in 0, you get 0. All right, so based off of that, what do we figure out? So we have an absolute max of what? 15 at x equals -1. And then f has an absolute min of -48 at x equals 2. Yeah, I think so. No, right now we're just concerned with finding the absolute and the absolute min. That comes later. That's like 4-3. We'll talk about that. Yeah. Yes. Critical values can't appear at endpoints. Right. Yeah. So you can have an absolute max or min at an endpoint. You can't have a relative max or min at an endpoint. Or a critical value. Right. Yeah. Yeah. Say this was like 20. It would be the same thing. F has an absolute max of 20 at x equals 0. Yeah, you have to test all of them. Well, you only have these will only occur at either endpoints or at critical values. That's what our definition says. So we only need to be concerned with when the derivative is equal to 0 or doesn't exist, and then also the endpoint. All right, number 8 says determine if it applies, and then if so, find the extrema of g of x on the interval from -8 to 1. Okay, so is that continuous from -8 to 1? Right, so cusp is continuous, but it's not what? It's not differentiable where? Which is where? The x equals 0. X equals 0, it's going to look something like that. That's just kind of an equation you need to kind of remember. What's that? Yeah. So it's continuous, but it's not differentiable. But we're not really concerned with that. We just want to make sure that it's a continuous function. That's what the graph looks like in x to the 2/3. No, this should be at 0, 0. Say again, Mike? Three-fifths would look a little bit different. Yeah. Right. Well, it'll either be a cusp or a vertical tangent. For this one, it is. You'd have to graph it. I don't know how you would. You just kind of have, like, x to the 2/3 is just a simple one you kind of need to remember. More remember, recognizing that you have an exponent, that tells you a sharp turn. A fractional exponent. Yeah, I think 3/5 would be something like this. Right. No. But you're taking the cube root now instead of the square root. Square root makes it positive. Square root makes it positive, so. There's words coming out of your mouth, but I don't understand it. Yes. All right, guys, you just listen up. You just need to make sure that your function is continuous. That's all you need to check. So, yeah, I think that's the rule. Yeah. So g of x is not differentiable. Continuous and differentiable are two different things. But you still might be able to find them, but since it will apply, we're definitely going to get a max and we're definitely going to get a min. That's what DVT says. All right, so my derivative would be 2 minus 2x negative 1/3. All right, so I got 2 minus 2 over cube root of x, right? Okay, so you're trying to see where does g prime of x equal 0. So you have 2 minus cube root of x is equal to 0. And what did you get? 1. Okay. Alright, so I got 2 cube root of x is equal to 2. I have the cube root of x is equal to 1. So x would have to be 1. Is 1 in my interval? Alright, so we're gonna keep it. Well, you can label it really as either one, endpoint or critical value. Now, where does the derivative not exist? 0, correct. Is that in my interval? Okay, so I'm going to have to test now -8, +1, and 0. So, well, if you plug in 0, right, yeah, if you plug in 0 here, you'll get 2 minus 2 over 0. So, all right, so we got g of -8, we have g of +1, and we have g of, what do we figure out? 0? 0. Mm-hmm. All right, so that's my original equation. So if I plug in a -8 into my original, I get -16. I get the cube root of -8 is -2. -2 squared is 4. 4 times 3 is 12. So -28. If I plug in 1, I get 2 minus 3, which is -1. And if I plug in 0, I get 0. So what does that tell you? A max of 0 at x equals 0. Yeah, you can either write max or absolute max. They mean the same thing. But if you were saying if you have a relative min, you need to include either relative or local. X equals -8. That's where the derivative doesn't exist. Right. If you had like a rational function, where we had like a vertical asymptote or something like that, and your vertical asymptote was somewhere in your interval. Like if you had 1 over x minus 2, right? You have a vertical asymptote at 2, right? But if you were taking the interval from 0 to 4, you'd have to take that into consideration. Yes, Samantha. Shannon, are you good? Sam mess up? All right. Number 9, determine if the EVT applies. If so, find the extrema from 0 to 3 pi over 2. So you have 2 sine of x and cosine of 2x. Sine and cosine are both what? Continuous when? When are sine and cosine continuous? All the time, right? So they're continuous all the time, so they're going to definitely be continuous from 0 to 3 pi over 2. It has to be continuous on the interval given, yes. You could say, h of x is not continuous, so the EVT does not apply, but you'd still have to kind of see, h of x is continuous for all x. So the EVT will apply on 0 to 3 pi over 2. Say again? This means all x in the set of real numbers. You gotta have to do like the double line at the back. It's the same thing. That's the same thing, yeah. All right, so you guys are pissing them off, right? What's my derivative? 2 sine of x is going to become 2 cosine of x, and then derivative of negative cosine of 2x is going to become what? Positive sine of 2x times the derivative of the inside, which is 2. Sine of 2x. Okay, so we're trying to see where does that equal 0? So if I have 2 cosine of x is equal to negative 2 sine of 2x, so where is cosine of x equal to negative sine of 2x? All right, so no. It might be. Because you have the derivative of negative cosine, right? Derivative of cosine is negative sine. You have the negative out front, which gives it a positive. And then you have the derivative of 2x, which is 2. Yes. Yeah. Where are you getting the negative 2 from?
Sine is this over this.
Right.
2x is 2 over this, and negative is negative 2 over this. And then cosine is negative 2 over this.
Right. So I'm thinking like the only places where sine and cosine are the same are at like pi over 4, 3 pi over 4. Right. I know that. Yeah, that changes it. All right. What does what is sine of 2x turn into? Are you just saying things? All right, sine of 2x turns into 2 sine of x cosine of x. All right, so this is 2 cosine of x. Double. Okay, so when what can I take out? 2 cosine of x. All right, 2 sine of 2x turns into 4 sine of x cosine of x. Okay, so again, you take half of the angle and you double the number that's on the outside. All right. It only works for sine of 2x. So you can take out a 2 cosine of x, right? And you're left with 1 plus 2 sine of x. So you're trying to see where does 2 cosine of x equal 0, and where does 1 plus 2 sine of x equal 0. So cosine of x is equal to 0 at pi over 2 and 3 pi over 2, right? You're supposed to know your unit circle. Yeah. No. I've been having to do my midterms are due tomorrow. I'm working on that. All right, where is sine of x equal to negative 1/2?
Do the backwards squiggle.
7 pi over 6. Okay, so I'm going to have to test 0, pi over 2, 3 pi over 2, and 7 pi over 6. All of those are in your interval. So you have h of 0, you have h of pi over 2, you have h of 3 pi over 2, and then h of 7 pi over 6. All right, so these pi over 2 and 7 pi over 6 are critical values. 0 and 3 pi over 2 are endpoints. Yeah, we're going to have to test them anyway, so. Pi over 2 is a critical value. That's where the derivative is equal to 0. And then 3 pi over 2 is an endpoint, because that's what they give you. Okay, so if you plug in 0, you get 0 minus cosine of 0 is 1. So you get negative 1. Pi over 2, 2 sine of pi over 2, sine of pi over 2 is 1. So times the 2, which is 2, minus 0. Three pi over 2 is negative 2 minus 0. And then 7 pi over 6. Yeah, it's between 0 and 3 pi over 2. Yeah, we're only looking at from here to here, and 7 pi over 6 is over here. So sine of 7 pi over 6 is negative 1/2 minus 2 times 7 pi over 6 is what? Seven pi over 3, which is so pi over 3, right? Cosine of pi over 3 would be 1/2. Well, you simplify this, right? And then 7 pi over 3 simplifies. You got to think of like the unit circle. It keeps going around, right? So 7 pi over 3 would be like one time around and then stopping at pi over 3. So this angle here has the same coordinates that this one does. So you got negative 1 minus 1/2. You got negative 3 over 2. All right, so your max is where? Right, and then your min would be at 3 pi over 2. All right, so you have a max of 2 at pi over 2, and then you have a min of negative 2 at 3 pi over 2. You want me to do that? Would that make you happy?
Why do they need the whole explanation?
You'll mostly see this probably on like a multiple choice question, this kind of question.